My name is Emma Hart. I'm a professor at Edinburgh Napier University, where I lead a large centre called the Centre for Algorithms, Visualisation and Evolving Systems, and within that a particular group that's focused on nature-inspired computing. So for me, AI is a really broad topic that covers anything basically where a system is solving a kind of task that a human might find complex. So that can cover anything from optimization, where you want to find the best route for a delivery vehicle to travel in order to minimize carbon emissions, let's say, to work in robotics, to work in natural language, to work in playing computer games. So I think it's a really broad topic. So mainly my work is obviously focused by looking at nature and trying to really understand what are the high level concepts that we observe in natural systems that we'd like to replicate in artificial systems. So my work has been really guided by two things. So work in natural evolution, but also work in artificial immune systems, which is taking inspiration from the natural immune system, because both of these systems exhibit the kind of high level properties we'd like computational systems to exhibit, such as responding to change, responding to unknown situations, being able to adapt very quickly to changing environments. So for me, lifelong learning is probably the most important aspect of artificial intelligence that we need to be focusing on today. So in the past, we've worked very much with systems that we train in some manner to do a task very well. So maybe it's a robot to do a task, or maybe it's a system to play, let's say, AlphaGo. And then we just field that system, we just get it to do the job we wanted it to do. And we don't do any further training, but it's not how people work. We're always learning, we're always making use of past knowledge to do things better in the future and to be able to adapt that knowledge to new situations. So for me, I think we should start to build systems that never stop learning. We just don't put them out there to do a job. They have to continue to learn. And I think there's really two really important aspects for that. So I call these adaptation and innovation. So the first is systems should adapt to small changes in their environment. So as they get more experience, or as things start to change around them, they should make small changes to themselves in order to do whatever it is that we as humans want them to do better. But sometimes the environment changes so much that the kind of current method of doing something isn't sufficient. And then the systems need to be able to innovate. So they need to be able to kind of invent or come up with by themselves completely new ways of doing the task that they're supposed to do. So I think we're starting to see methods to do this with automated design of algorithms and design of software. But I think both of these aspects, the adaptation and the innovation, are really key to getting a system to learn over very long periods of time. So I think evolution is a perfect example of a mechanism in nature that provides adaptation. And again, it provides adaptation on essentially two timescales. So it can provide very fast adaptation to deal again with small changes, but as we know, like over generations and long periods of time, it also provides adaptation to bigger changes in the environment. And I guess we can also see it as solving, if we think about it from an optimization perspective, solving a search problem. Evolution has to find the combination of genes that gives rise to some organism that is fit for the environment. And so in the same way, we can model that in computational systems to try and sort through vast combinations of possibilities to make a solution to give us the best one possible. So for me, it's bringing it back to this idea of lifelong learning and building systems that never stop learning, not just, so we've come a long way, especially in the last few years. I guess everybody knows about the advances in deep neural networks and things like that, that are allowing us to use vast amounts of data to do things like play games, natural language type things. But for me, that's only a small part of the problem, I guess. I think what we need from evolution is systems that don't need vast amounts of data to learn. If we're going to, for example, take a swarm of robots and put them on an unknown planet and want them to explore it, we don't know what the environment's going to be like. We can't train that system with vast amounts of data because we don't have it. So I think we need evolutionary computing to be looking at these applications where the system has to learn very quickly by itself with very little data and very few examples, and maybe it's got to learn very fast in order to survive and complete its tasks.